Thank you all for having us. My name is Shlomy. I'm the CEO and co-founder of GreenQ. Those days there are a lot of IoT companies, and I feel quite delighted to be a CEO of a company that is the only IoG company. IoG, Internet of Garbage. So this is actually what we are handling. We are monitoring and optimizing waste collection. I'm going to use the upcoming few minutes. It's like kind of warm-up before my co-founder, Eddie, which is our CTO, is going to step in and explain to you all about the technical side of the usage that we're doing with serverless services, to explain why are we doing that, and a little bit about the company's way at the last 2 years. So I think that a nice starting point for this trash talk can be the history. Yeah. So if you look at waste collection, you actually see above the timeline the progress of the technology. You can see the first motorized waste collection truck, after that the dumpster, the compactor, and at the 70s you see the residential canister that we all use. Under the timeline you can see the progress of the monitoring. You can see manual, 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 and then at the beginning of the 90s, for the first time, you see the RFID tags that were attached to bins, and then the truck was reading them. After that, something like 15 years from now, you can see the first smart bin. You're familiar with that idea? A bin that is measuring the capacity of the waste. But the most interesting thing for us, at the beginning of last year, when we learned this market, was that nobody is using these technologies. You see a very, very low penetration rate. So we understood that indeed there is a great need in understanding how many waste is being collected from each spot, and everybody wants to see where his truck is and what the truck is doing, but the technology is not good enough. It's too expensive to use any bin on one side, and it's not enough data if you just know that you have met a bin, but you don't know how full was it. So we decided to develop a system that will be a truck-based. You are installing just on the truck, but will give you also the capacity level of the bin. So we have done our first system, and now it's a good time to see a little movie about Max. Without audio. Audio, please. Start from the beginning. Are we good with the audio?
Somebody set it down.
Okay.
There's noise. We don't have an element. It's not coming through.
Okay, so I do the audio. Max is in charge of waste collection in Samuel City. And you have a lot of issues with waste collection. Wait a second, from the beginning. If I'm doing it, so all the way. Now, you have to plan the waste collection of his city. You have a lot of things to take into consideration when he's planning the waste collection. For example, he wants the trucks not to move in front of schools in the time that the children are getting into the school. There are issues with scheduling. There are issues with the bins that you don't know how many waste is being collected from each spot of the city. You don't want to collect half-empty bins. And you don't want to create traffic unnecessarily inside the city. So we decided to use GreenQ system. Now, with our system, you can now manage better the waste collection and actually saving public money from being thrown away to the bin. Now, this is the typical situation in the modern world of waste collection. This is two numbers, okay? You are collecting half-empty bins, and you actually use the money in order to create smoke inside the city center. With our solution, we made the waste collection smart track, and then you have the data about each collection, about the capacity, about the can ID, about the position, about the time. You can already imagine that there is somewhere that the data should be sent to. At the end of the procedure, you have it all in your fingertip. We also provide online monitoring, including all kind of notifications, all kind of reports, and of course optimization. We gained in Israel for the first time 53% less of waste collection OPEX. Now, why is that interesting? Because now we see that we have the ability to have this huge number, $23 billion every year, prevented from being thrown away to the bin. And when we understood this, a little bit less than 2 years ago, we actually understood that there is a big, giant competition that is running behind us. So we have two main goals for our system. First is time to market. We have to go to the market very quick. And after that, we are handling large-scale operation. We need to scale up very quickly and to do it the proper way. Now, there is another interesting thing, that we are bootstrapping, so we don't have money. Now, for all of these interesting challenges, Eddie was stepping in. I now will call Eddie, my co-founder and CTO, to explain simple question, how?
Hi,
Welcome.
Hi, good afternoon. I'm Eddie. I'm from GreenQ. And I'll try to give you a short brief of our system and just tell you how do we do it. First of all, I'd like to give you a short brief of our general architecture. Here you can see the devices. The devices can be truck devices, or they can be any smart container or smart bin devices. All these devices transmits their data, and the truck itself can transmit also the capacity level and the timing of each waste bin collection. Everything is transmitted via cellular communication to our cloud-based system, and the user can log into the dashboard from any device, from his phone, from his computer in the office, and can just get all the information that we can share with him. Okay, so after this short brief of our architecture, I'd like to dive in and to drill in the devices that we have, and after it in our system. Okay, here you can see the main and the most important device that we have. This device is the truck's device. This device is installed on the truck itself, and it enables us to get for each waste bin collection when and where was it collected from and how full was it. How do we do it? We have an onboard computer on the truck itself. This computer has a few sensors which are connected to it. The sensors are, for example, the dynamic weighing system. This system enables us to measure the forces that the waste bin itself is applying on the lifter during the pickup, and to store it in the computer. We also have the GPS that enables us to get the location of the collection, and of course we have a camera that helps us to add more notifications during the monitoring issues. All of this information together is transmitted via cellular communication to our system. Another device that we can see here is our smart container device. This device has a few options. We have a few sensors that can be attached to, and it can be installed inside an underground container, big containers which are underground, and inside portable waste compactors. And it enables us to get the filling level and the capacity of the waste in this container, and send it via narrowband IoT communication, which is a kind of low power cellular communication, to our system. This is basically our devices. And now I'd like to show you the first system that we have made when we had to do it fast. We have developed a server-based system, and this is its architecture. As you can see, we have the devices there on the left. These devices transmit their data to our system. In order to get this data, we had to maintain two services. We had to maintain a secure web server for our secured FTP communication for all the files and the images and videos and all these things, and an MQTT server that gets all the short messages from the devices. Having all the messages and the files to the system, we have to deal with them. So what do we do with them? We have the first service is our location service. This service is taking care about everything that related to location, take care of it, do what it's supposed to do, and insert the information to our database. All the waste data, all the information about the amount of the waste and all the raw data that's coming from the trucks is dealt using the analyzing services. We actually check if the information is valid. If it's valid, we check what analysis type should be done, and then make this analysis and insert the analyzed data to the database. We have online algorithms here on the notification services. We have online algorithms that are running all the time. These algorithms actually check if the waste collection procedure is working good or not. If there are some problems, maybe the truck is getting late, maybe the crew is not doing the job very well, we get a notification, and we send it to the users via our dashboard or SMS messages or email messages, what the user wants to. So after we can see that we can get the information for every waste bin and the time of the collection, we actually can generate a function that describes the waste production rate of this specific waste bin. So we actually can predict how much waste will this specific waste bin or specific household will produce. And when we zoom out, we have like a map of the waste production rate of the entire city, which is actually our logistic problem. So we take this problem and we take the policy of our user, which is usually the hauler or maybe it might be the municipality. We mix them together, and using our optimization services, we help them to optimize the waste collection procedure. We give them some recommendations like better routes, better frequency of waste collection for every area, maybe to change waste bin mapping, waste bin types, waste collection trucks, and everything that related to these issues. All these things that we can see here can be viewed using our dashboard. So we have a user interface server that the user can log into and see a map. You can see all the trucks online, you can see the roads, you can see every waste bin, you can click on them and get the specific information if you want to dig in. It has some statistics regarding the waste collection procedure. And of course, that you also have, you can see and get the notifications if there are. If the user wants to have some reports, you can do it using the dashboard. You can actually generate a report using our reports generator. So this is basically our system. But our system is not a standalone system. As one vector of the smart city solutions, we have to connect to another systems, such as the city management system, or such as the application for the reports that's coming for the residents of the city. And all the interfaces are made using the API server that actually gets the transaction, checks if it's valid, and after it checks if the user is permitted to do it, and then sends them back the information or update the information in our databases. So basically, this is our system. This is the logic of our system, and that's what we did when we started it, when we did it server-based. So it's working good. It's working pretty good, as long as we know what N is. And we don't know. We don't really know what N is every time. So basically, our challenges when we came to the scale-up was scalability, performance, and cost. What is scalability? Scalability is the number of the trucks. We don't know how much trucks will collect the waste every time exactly. We don't know how many containers and how many bins will be collected or has been collected. And of course, we don't know the timing of the activity because it's something that is changed according to the country, according to the city, according to holidays, according to another special events. And all of these issues affecting the performance. So our performance is depending on the unexpected events, which is something that is it's not easy to predict. So, but we had to do it, we had to make it right. And of course that we also have the cost issue. And we don't want idling VMs, and we don't want to invest too much human power in maintaining servers. So this is actually what the problems that we encountered when we scaled up. So we thought about solutions. The first solution that we thought about was to check what the balance is and to manage virtual machines according to that. It's too complicated, too much managing time. Too much, okay, this machine is working, it's too high load, lower it up. It's just can't work. The second solution that we thought about was Dockers, using Dockers, which is a pretty good solution, but still needs to be managed. And then we examined and checked OpenWhisk. And we decided to go serverless using OpenWhisk. This is now our serverless system architecture. This is how we work. Here you can see that we all still have our devices there on the left, transmitting the information using MQTT and secured FTP. We have services. We are using IBM Bluemix infrastructure, so we have services of the secured FTP and the MQTT services, and all the information actually is taken care of by them. So every information that we get, every data that is coming from the devices is mapped into the specific trigger that's supposed to be made, and after it, every trigger activates or invokes another actions that should be made according to this information. All of these serverless issues is managed by OpenWhisk. As you can see here, we still have all the issues that I spoke about them before, so I will continue. I'll not repeat what I said. Here you can see a short description. The set, okay, it's pretty small here in this screens, but you can contact me later if you want to. Here you can see actually the set of the triggers and actions that we use in our compute, in our system. I'd like to take a closer look on some of them, and then you'll be able to see how exactly do we do it, because we use triggers not only for the information or for the data that we get from the devices, but also for requests from the user interface or from the APIs. Here is, we can see the most common information that the system gets. This is the truck location. The GPS transmits location every 1 second. We take this information in the device, and the device transmits the information to our system every 10 seconds. So there's a lot of information that we have to take care about. So every truck location update, which means, an MQTT message that the user gets, that the system gets, is a trigger. So the location update is a trigger, and it activates 2 actions. The first action is just insert it to the database. The second one is the alerts handler. The alerts handler actually checks what is the location. Is it good? Should we do something about it? Should we notify someone about any irregularity of this location? If not, we do nothing. If yes, we have to send notifications. So we can send them by using email, SMS messages, and of course that we insert it to our database. Another example is one of our most compute resources consumer in the system. This is actually the raw data file analysis. Every truck, when it gets the information about the specific waste bin, transmits a file, uploads a file to our system. So this file upload is a trigger. When this file is uploaded to the system, we activate the first action, which is the check analysis type. This action actually checks if the file is valid. Is it good or is it corrupted? After it, we check what analysis type should be done. And then we are invoking the specific analysis type that should be done. And we take the information that we got from this action and then insert it to our database. Another example is the device status update procedure. When a device status updates, a message is arrived by using the MQTT. So it is considered as a trigger, and it activates two actions. As you can see, we update the device status, and we activate also the alerts handlers, because we should see, okay, if the status is being updated, we should taking care of it, maybe to alert someone to go and fix the device type on the truck, or maybe there's a problem with the communication or something like that, so we should alert the people who are in charge. So we activate the actions according to the status, and of course, updating the system log. The last example that I'll show you here is our API request triggering. Every API request, or every user interface request, is considered as a trigger. So in this way, we don't have to be afraid of how many API requests will we have. It depends on a lot of systems, depends on the specific time of the year, if it's a holiday or not. The other systems that we are interfaced with don't have the same rate of API requests all the time. So we have to deal with something that maybe they have low rates, sometimes they have high rate of API requests. So every API request is activating the API requests handler. This handler is checking if the transaction is valid and if the user has the right permissions, and then activate the API activity as needed. And after it, of course, that we return the data, we generate the report and return it to the user, or updating our system log. Basically, this is our system. I hope that I managed to show you how serverless is making our life easier, because we don't have to be afraid of scale up, about rates, about these issues. I believe that just before we're moving to the Q&As, I believe that one of the first questions might be, why OpenWhisk? I'll try to give you a short answer about it. The first thing is that OpenWhisk is open source, and there's a great community of developers that supports it. We always want to know, in the things that we use, what's under the hood. We want to know how exactly things work. And if needed, we also always wanted to have the ability to fine-tune it if we have something specific that we'll have to do specific for ourselves. So open source is very good for us. Another issue which is related to open source is that in GreenQ, we are actually something like a B2G company. We are working sometimes within municipalities. Municipalities sometimes want to work on premise, not on a public cloud. So we must have this option. And when we are using open source based solution, we can actually do it. Another issue is that we use Watson Cognitive Services of IBM. And using OpenWhisk, it's pretty easy to use it, and it even costs less. So basically, this is our system. I hope that in the minutes that are left, I'll try to give you an option to ask me some questions. If there's no time, you can ask me directly after this talk. If you have any questions. Yes?
Is this service available across the country?
This service is available, now is working in Israel. We are a company from Israel, and now we are trying to expand to the States and to work with this service as well. Yes?
Can you guess me how far are you with business part with the customers today, or just kind of prototype, or?
No, we have a few customers. We have a few paying customers in Israel. We are working with the biggest Israeli telco and with the biggest Israeli cellular communication provider, which are actually smart city integrators in Israel. So we are their solution for smart waste management. And of course, we have our customers that are working directly from us, the customers that wants only smart waste management, but not all the smart city solution. And we're working with them. We're working with Deutsche Telekom in Germany, and now we are looking for opportunities also in the United States. Yes? Yeah. Okay, so we have a lot of triggers. That's true, because we have a lot of types of different information that we should consider. Okay, we get this information, so we have to make a specific action according to that. So we have a few types of information. Depends if the information is coming from a truck and what kind of information is coming from a truck or from another devices. So we take all of this information, these triggers, and it makes us to have different actions according to that. The optimization issues is something that if we have a specific data, we have to run some optimization algorithms. And it is something that is very, very compute resources demanding. So we don't want to have some idling machine that will wait. Okay, if we have this information, we'll run these algorithms. So we are actually, if we have a trigger, which is something like a listener that checks, okay, if we have 1, 2, 3, this information, we can run the action, which is one action or a few actions, which actually compute power consumers, big ones. So it helps us because we don't have to have some idling VMs or things like that. We actually have to pay for what we're using, not for what we want to use. Okay? Any other questions? Okay, we are out of time, so thank you very much. Thank you. Have a nice day.